Good morning, sixth grade. Happy Thursday. We're almost there. Let's take on Power Up K here. It's the first time we've done that. The top of it is running square roots, and the bottom of it is running squares and a couple cubes. The square root of 100 is 10. The square root of 16 is 4. The square root of 89 is, the square root of 81 is 9. The square root of 4 is 2. The square root of 144 is 12. Square root of 64 is 8, square root of 49 is 7, square root of 25 is 5, square root of 9 is 3, and the square root of 36 is 6. Now the opposite direction. 8 squared 64, 5 squared 25, 3 squared 9, 12 squared 144, 10 squared 100. 7 squared 49, 2 cubed is 8. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 10 to the third power is 30, so it's 1,000, and 5 cubed is 125. Now, 6, I didn't get any of those wrong today because that's the first time we did it. I want you to have the correct answers. Your job is to make sure you can do those yourself, so when you get that on those power-up tests, you're ready to go. Mental math, A, multiplied $4.50. B, left twice, 0.045. C, if you reduce 15 over 5 to 3 over 1, you can just see it's 1 times 6, so 3 times 6 is 18. Convert centimeters to meters is divide by 100, so left twice, 2.5. 10 cubed, you just did as 1,000. 20 squared is 400. 1,000 minus 400 is 600. Divide by 10 is 20 times 9 is 180. How many different ways can you arrange those digits? Guys, I'm not even going to consider the digits. I'm just looking how many there are. There's 4 of them. So remember, that's a permutation question for G. So it's literally just 4 times 3 times 2 times 1. So 12 times 2 is 24 times 1 is still 24. So G is a 24. It's a permutation question. 80 kilometers per hour, how far will they travel in 2.5 hours? Well, what I did in my head is I did 2 times 80 is 160. Half of 80 is 40. 40 plus 160 is 200 kilometers. Problem solving, it says, what is the largest 2-digit number that is divisible by 3 and whose digits differ by 2? So I start at the largest 2-digit number that when I subtract, they have a difference of 2. Then I said 9 plus 7 is 16. 3 doesn't go into 16. So then I went down to 86. Still has a difference of 2. So that's my pattern. Add them together. That's 14. Not divisible by 2. Went down to 75. Still has a difference of 2. 7 plus 5 is 12. 3 goes into 12. And I have my answer. So the reason I started with difference of 2 instead of multiple of 3 is if I went with the multiples of 3, I'd do 99, 96, 93, 90. I'd have to list all of those and say difference of 2, no, 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 no. And I'd have to do a lot more. This is just 1 per set of 10. I got there in only 3. Make sure it meets both criteria. Okay, guys, today we have order of operation. Math has its own way of doing things that we need to keep in mind here, and order of operations is what we're going to talk about today, and it's going to lead to a lot of fun for the rest of the year. This can be very challenging to us if we are not thinking orders of operations. It says, recall that the 4 fundamental operations of arithmetic are addition, subtraction, multiplication, division. We can also raise numbers to powers or find their roots. When more than one operation occurs in the same expression, we perform the operations in this order. The first thing we do is simplify anything inside the parentheses or other symbols of inclusions. That'll come in a second. We work from the inner to the outer because there's going to be times where there's way more than one parenthesis. Number 2, then we use the powers and the roots, what we call the exponents. 3, then we multiply or divide as we work from left to right. So it doesn't matter. Multiplication and division, guys, work together as you move from left to right. 4, then you do all the addition and subtraction as you work from left to right. It says, note at the bottom, symbols of inclusion set apart portions of an expression so they may be evaluated first. The following are symbols of inclusions that we're going to use, whether they're parentheses, brackets, ellipses, and the division bar. I do on top as I do on the bottom. Okay, turning the page, guys, it says this. The initial letters of each word in the sentence, please excuse my dear Aunt Sally, remind us of the order of the operation. So please, do everything in parentheses. Excuse, do any exponents. My dear, multiplication or division, doesn't matter. Aunt Sally, addition or subtraction, it doesn't matter. So this is what we're doing. I got 2 plus 4 times 3 minus 4 divided by 2. I start with please. There's no parentheses. I start with excuse. There's no exponents. Now I'm doing multiplication or division. So this is the first thing, and this is the second thing here, guys. So 2 plus stays the same. I do the math. That's 12. Minus stays the same. I do the math. That's 2. Then I start over. 2 plus 12 is 14 minus 2 is back down to 12. Okay, let's pretend we did it wrong. We just went left to right. 2 plus 4 would have been 8, times 3 would have been 24, minus 4 would have been 20, divide by 2 would have been 10. So does order matter? Absolutely. You'll get a completely different answer. Example 2, you have 3 squared plus 3 times 5, all of it divided by 2. Okay, exponent says do it first, so that's the first thing I do. That's a 9. Multiplication comes before this addition. So many times, guys, what we do is we do 3 squared is 9 plus 3. No, multiplication next. That's 15. Then I add 9 plus 15, and that gives me 24. And because, guys, this is a symbol of inclusion, I do everything on top, then I do everything on the bottom, and the last thing I do is actually divide. Now, there's nothing to do on the bottom because it's just one number, so I do 24 divided by 2, and once again, I get an answer of 12. Example 3, they try to make it a step harder by giving it to you in letters, which looks like this: 3 plus 3 times 4. Now, guys, life would be so much easier if they just wrote my math problem like this, because then I could just work left to right. But you're going to notice they do this all the time. They stick the plus first to see if you get messed up and add first. Multiply first, because that comes first. 12 plus 3 equals 15. Okay, so you have to memorize that order of operation. And number 4, it says x is 9, y is 2/3. Letters next to each other mean multiply. And then I'm going to subtract from it a 9 over that 2 there. Okay, so step 1, 3 goes into 9 3 times. 3 times 2 is 6. Now I have 6 minus 9 over 2. Okay, so I'm going to simplify that by dividing. 2 goes into 9 4 times. I have 1 left over. So now I have 6 minus 4.5. Too often, guys, we write down the half and we do the subtraction. You can't subtract from that. That's 5. You bring over 2 2's. Now you subtract, you get a half, and you get 1.5. Okay, last but not least, underneath example 4 says calculators with algebraic logic circuitry are designed to perform calculations according to the order of operations. Calculators without it just go in sequence as you type it in. You can test a calculator's design by selecting a problem such as that in example 1 and entering the numbers and operations from left to right, concluding with an equal sign. If the problem in example 1 is used and display is 12, you got a good calculator. Guys, what it comes down to is if you have a lot of buttons, it's algebraic. If you have just the numbers and add, subtract, multiply, and divide, and maybe like 3 or 4 other M1s, that's a cheap calculator. It just works left to right. Okay, so $2.99 calculators, not algebra. $9.99 and up calculators, yep, algebra. Okay, 6, you got ABC on the bottom, then turn the page, you got some more. I would highly encourage you to keep working order of operations. They're going to trip a lot of us up if we don't slow ourselves down. Too often we just get going so fast. We're like, I'm going to start working left to right. I'm doing those problems. And left to right in order of operation is never how we do it. Awesome. Let's get started on our problems. The first one we got is number 2. It says, can you compare 40 inches to 40 centimeters? Use a unit multiplier to convert those over. And it says 1 inch is 2.54 centimeters. So the first thing, guys, I'm going to do is I have to do 2.54 times 40. Now, if you're quick, you can go up. I know it's bigger because 25 times 4 is 100. So I know this is, because of this 4, a little bit bigger, but I'll just show you the math behind it. 16, 20, 21, carry the 2, 10, 8, 10. 1, 2, 1, 2. Don't need that 0, so I'm really comparing 101.6 to 100. It's greater than. Number 3, 25 and 217 thousandths. 25 and decimal point 217 thousandths is how much less than 202? 202 and 2 hundredths. And I'm comparing those things, so it takes a subtraction. You need to add a 0. Cross out the 2, make it a 1. That's a 10. That's a 3. 1 minus 1 is 0. Can't do the math. Cross out the 2, make it a 1. Make it a 10. That's an 8. Decimal point, straight down. Can't do that. 20 becomes 19. That's an 11. 11 minus 5 is 6. 9 minus 2 is 7. 1 minus nothing is 1. I have an answer of 176 and 803 thousandths. Great problem, teaching us to take words to math. Keep practicing that. I know you can get my numbers, guys, but your ability to do that is very important. Number 6, in the following statement, convert the percent to a reduced fraction, then diagram the statement and answer the question. 75% of the 60 passengers disembarked at the terminal. How many passengers disembarked? So 75% is 75 over 100. Divide by 25 over 25. 25 gives me 3/4. Divide by my denominator. Goes in there once. That's a 4. 20 is a 5. Multiply by my numerator is 15 is 45. My answer for A, how many got out? 45. Don't forget a label, guys, passengers. What percent of the passengers didn't disembark? 75 did. What didn't? 25% didn't. Working the opposites because the did and did not have to add up to 100. Number 8, in 2002, the automotive industry spent more than that much dollars on advertising. The oil and gas industry spent that much dollars on advertising. Write the first amount in standard form. So guys, I have 1.6 times 10 to the 10th. Remember how we did this from yesterday? I take the number exponent, I subtract how many numbers I have after my decimal point, which is 1. 10 minus 1 is 9. I have to add 9 zeros. 1, 2, 3, 1, 2, 3, 1, 2, 3. They spent $16 billion on advertising. Woo! That's a lot of money. Letter B, write the second amount in words. Well, guys, to do the second amount of words, the first thing I have to do is make it look standard form. So I have 2.4 times 10 to the 8. 8 minus 1 is 7. So I have 2, 4, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 1, 2, 3. So that is 240, and I'm in the millions. So 240 million. If you want, you could call it $240 million. Also, you can have commercials, right? I love it. Number 10, write that number rounded to the nearest thousandths. So I have 3.2727 tenths, hundredths, thousandths. Look here, 7 goes up, so 3.273. Number 11, our charts that we're continuing to have every single day. They're going to start to do this one to us a lot more, guys, where you're going to see a pattern. They gave us 250 here. Sorry, it should be 5, and a 25 there. Left twice, bing, bing, is 2.5. Left twice, bing, bing, is 0.25. Okay? As a fraction, this is 2 1/2. As a fraction, this is 1/4. We're going to start to figure out and see patterns as we do this more and more as you work through those. Number 15, you have that beautiful little quadrilateral and a lot of work to do with it. Okay, and then they said AD is parallel to BC. Find the area of ABC. So the first thing I'm doing is I'm finding this triangle on the bottom, guys. They gave me 12, my base. They gave me my height, that's 6. We know it's base times height divided by 2, so I'm going to divide that guy by 2 because I can do it in my head. 6 times 6 gives me 36. We're working with centimeters, guys, so it's 36 centimeters squared. It says find the area of ACD. That's this guy. So I have an 8 here, I have a 6 here. I'm going to divide that guy by 2, which is 4. I'm going to multiply, and I have 24 centimeters squared. C says, what's the area of the whole thing? Boom, put them together, guys. 10, 1, 6, 60 centimeters squared. They're literally preparing you to how to find area of this shape altogether, guys, is the area of a trapezoid. That's coming up in the future. Number 17, I have 12 over 15 equals W over 25. You might want to reduce this one. If I divide by 3, I have 4/5. How'd I get from 5 to 25 times 5? How'd I get from 4 to times 5 is 20. Now, it's not 25, guys. It's 2.5, so it's not 20. It's 2.0. How do I write 2.0? I write it as a 2. Number 20, we have 5 to the third power minus 10 squared minus the square root of 25. Notice this is from lesson 20, guys. This is an order of operation because I can literally work left to right. I have to do the math. That's 125, that's 100, and that's 5. So I subtract 125 minus 100 is 25, minus 5 equals 20. Number 21, guys, is from today's lesson. That's order of operation. So please excuse, no parentheses, no exponents. My dear, I'm finding all the multiplication and I'm finding all the division. So this front thing stays the same. I do the math, that's 16. The subtraction sign stays there. I do the math, that's 1. Left to right, 20 minus 1 equals 19. So hopefully you're seeing how we're doing those things. Number 22, I have 4.8 on the top minus 0.24. Have to add a 0. Cross it. 7, 6, 5.4. On the bottom, I have 2 times 6 is 12, but it's 1, 2, 1, 2, so it's 1, 2, 1, 2. Now I have the division. Top in. Bottom out, so I have 4.56 divided by 0.12 over, up. I'm doing 12 into 456. Ooh, sorry. That goes in there 3 times. That's 36. That's a 9, bring down a 6. That goes in there 8 times. That's a 96. I'm done. My answer is 38. 23. Love it. We got 5, 45, and 30, 2, 53, and 55. I'm going to add them all first. So this is 5, 8, 8, 9, and a 7. Now I'm going to simplify. How many seconds? There are 60 seconds in a minute. So I divide by 60. Gives me 1 more. I do my subtraction, that's 5, that's 2, so I got 25 seconds. I now have 99 here. How many minutes in an hour? That's also a 60. 60 goes into 90 1 time, and I subtract 9 minus 0 is 9. 9 minus 6 is 3, so there's 39 minutes, and then 1 plus 7 is 8, and there's 8 hours. So guys, the addition and then the simplification, working our way through that. 25. 3 times 4 is 12 plus 3 is 15 over 4 divided by 2. Stay, change, flip. 15 times 1 over 2 gives me 15 over 8. I'm taking that answer, guys, and I'm subtracting it from 5 and 1/2. So I'm going to simplify this to 1 7/8. So I have 1 7/8. Common denominators would be 8, so this would be 4/8 minus 7/8. Can't do that. So I'm going to cross out the 5, make it a 4. Add 8 to that gives me a 12. 12 minus 7 is 5. 8 stay the same. 4 minus 1 is 3. And I have an answer of 3 5/8. 26. Estimate the sum to the nearest whole number, then perform the calculation. Okay, so 8.575 would round to 9, plus 12.6 something would round to 13, plus 8.4 would round down to 8, plus 70.4 would round to 70. Now I'm just going to add those together. 9 plus 3 is 12, plus 8 is 20. Carry the 2. 2 plus 1 is 3, plus 7 is 10. So my estimate is 100. Now I have to do the real deal, guys. So I got 8.5. Oops. I'm going to write on a new piece of paper. I have 8.575. I have 12.625. I have 8.4, and I have 70.4. Notice how my decimals are lined up. 5 and 5 is 10. Carry the 1. 1 and 7 and 2 is 10. Carry the 1. 1 and 5 is 6. Plus 6 is 12. Plus 4 is 16. Plus 4 is 20. Carry the 2. 10, 20. Carry the 2. 1, 2, 3 is 10. Decimal point straight down. Those things all go away. Guys, so my estimate was exactly the same as the actual answer. They're both 100. That normally doesn't happen, so don't think that that should happen all the time. And 28. I have 4 and 0.5. So the first thing I do is I have 4 times 0.5, and then I'm taking 4 divided by 0.5, and then I'm going to add those two answers together. So 4 times 5 is 20, and 1 decimal point goes right here. It's the answer of 2. This is top in, bottom out. Over once, over once. 5 goes into 48 times because my decimal's now over there. 8 plus 2 equals 10. And my answer is 10. All right, guys, done with lesson 52, order of operation. That's a big problem lesson for us. We're going to have this one a lot into the future. Happy Thursday, guys. Hope you have a blessed break. Tomorrow, your big assignment for Friday is can you hand in your folder here. So make sure you got all your stuff together. Make sure it's all done. Hopefully, we'll see you at school tomorrow running this packet in, giving you a little craft to go along with it. I hope you guys have a blessed, blessed Christmas. And we'll see you back